Welcome to our next topic in advanced mathematics. During our time in this one, we'll be looking at coordinate geometry. Now, to get us started, we will do a quick revision of some basic terms that we should all understand by this point, and there's something that are just going to be used a lot from here on out, so we need to know what they are. So starting with coordinate geometry, we definitely need a number plane. Now, a number plane is, as you see in front of you, it is the graph there, and it is made up of two aspects of itself. It is made up of our x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis. After that, once you have your x and y axes, you are able to plot coordinates. Now, coordinates are simply just one point on our x and y axes in our number plane that are represented by two numbers. So a coordinate we usually write in a couple of brackets separated by a comma, and it is typically written as an x point and a y point. Now, the way we know what those x and y values are, it corresponds to the values that that point lines up with the x and y axes. So along our x-axis we have it lining up with 5, and on the y-axis we have it lining up with 5 also. So you have a very definite way of knowing where each point is on a number plane because of the x and y axis. If we have another point on the line, say we're going to have another point over here, this point is represented by -5 on the x-axis and 1 on the y-axis. Just a quick revision on how to know what numbers are the x and y values. Always start here in the middle at the origin and count your values going from left to right first. So to get to this second red point that we just put on, you need to go back 1, 2, 3, 4, 5. So that's where our -5 come from, and you needed to go up 1. So that's where our 1 came from. Now, if we were to draw a line connecting our 2 points, because this line does not go on forever, it finishes at 5, 5 and starts at -5, 1, we call this an interval. And this is typically what we're going to be dealing with in coordinate geometry. We're going to be dealing with a lot of intervals. As you can see, there are a whole lot of words there. We just explained a few of those. We had a look at what is an x and y axis, what is an interval. We had a look at what is a coordinate, what is a number plane. This short video will be focusing on calculating the distance, calculating the midpoint, and calculating the gradient of any given interval. So let's jump into it. The first one we're going to look at is the midpoint. Something in coordinate geometry you're going to be asked to do a lot is calculating a midpoint of an interval, a midpoint of a line. The words vary, but the end result remains the same. So just a quick little brainstorm about how we normally find the midpoint of something. So we're trying to roughly work out where the middle of this line is. There is a very definite and distinct way of doing it. We don't just have to guess and pull out a ruler, put a line in the middle, there's our midpoint. Our midpoint needs to be represented by a coordinate of itself. It needs to be one definite point on the graph that is in the middle of our line. If we tried to work it out just with the line given as is, it would be extremely difficult. What we can do, and what a lot of our rules today will be focusing around, is making triangles, little right angle triangles more specifically, with our intervals. Once we have this, we can easily work out what is the middle of this line and where is the middle of that line. Once we've got that, we can match those up much like an x and y coordinate to find the middle of our black interval there. How do we work out the middle of these two lines on the outside? Going with the bottom, so this green one here, we're talking about the x-axis, and remember in coordinates your x value is first and then it's your y value. Down here it is the same. X always comes first in a coordinate, followed by the y value. So we're going from -2 all the way to 6. So that means we have a gap of 8 down here. On our vertical line, which is the y-axis, we are going from -2 to 7, which means that line has to be 9 long. To work out where the middle of 8 is, we halve 8, which gives us 4, and we go across from the start and go 1, 2, 3, 4. So here is the middle of our horizontal line. 9, half of 9 is 4.5, so we go up 1, 2, 3, 4.5. So there is the middle of our vertical line. Matching those up, so we go across, meet the line, going up, meet the line, and there is the definite midpoint of our line. Now, as I said, midpoints have their own coordinates, so we need to know the coordinate of that line. If we've gone from -2 across 4, that means we would be at 2. And if we have gone from -2 up 4.5, that means we're at 2.5. So the midpoint of that line, which we represent by a capital M, is 2.5. Now, that seems a lot of work. It's not all the time we will be given a graph and an interval to work with. Most of the time you'll just be given simply 2 coordinates and asked to find the interval. So here we have a bit of a rule to help us out. As it says, the midpoint, the capital M, of the interval joining 2 points x1, y1 and x2, y2 is the point given by the following formula. Now just quickly, having a look at these x1 and y1 and x2 and y2, it's very easy to get confused as to what the 1 and the 2's actually mean. Now, notice that they're on the bottom of the numbers, not at the top, so they're not squaring the x's or squaring the y's. They're not a power. They are simply just a way of labeling this first point. Because it's x1, y1, that is simply just point 1. This second point, because it's x2, y2, we use those 2's to say that it is simply a different point and it is point 2. So here, when we come to the formula, and we've got x's and y's coming from 2 different points, we know what actual numbers we're using because we've labelled each point 1, 2, 3 or 4, depending on how many points we're actually given. So here, we're saying in our formula, to work out the middle of the x values, you add the 2 x values you're given together and then halve them. So if we add our 2 values together of -2 and 6, we get 4, and halving 4, we get 2, which is what we got in our midpoint. If we add our 2 y values together of -2 and 7, we get 5. Half of 5 is 2.5, which is what we got in our midpoint coordinate. So we know we've done the right thing. We know this formula works because it works for what we did the very long and tedious way. So now we're going to stick to this formula. To work out the middle x coordinate, we're going to add our 2 x values together and then halve it. And to work out our middle y coordinate, we're going to add the 2 y values together and then halve them. And that will give us our midpoint straight away. We're not going to do an example right now. We're going to do one big one at the end with our 3 little skills that we're learning. So we will continue with our next formula. Our next one is the distance. You will be asked many times to calculate the distance of an interval. Now, because it's on a slope, you can't simply say that we went from -7 to 7, so therefore it's 14 long. That's not quite correct, but it is getting there. What we can do again is make our little right angled triangle, right so. Now, we did say we went from -7 to 7 along the x-axis. Remember, the x-axis is the horizontal one and the y-axis is the vertical. From -7 to 7, that means we went a total distance of 14 along the x-axis. And going from 2 to 8, that means that we went 6 up. So from our first point over here of point A, we went across 14, up 6, and that got us to our point B over here. Now, if we label this just with a sneaky little letter C, hopefully a lot of you can see that we are given a right angled triangle and we are trying to work out the longest side. So this is Pythagoras. And we would go through the steps like normal. We would say Pythagoras said c squared, or the hypotenuse length squared, equals the square of each side added together. So we end up with 14 squared plus 6 squared, and you would go through the process and solve that. So 14 squared would give you 196, 6 squared would give you 36, adding those together you get 232. Then, because it's c squared, c is equal to the square root of 232, which gives you 15.23, roughly. Now, because we weren't given any units on this question, we don't know if it's centimetres or metres or what kind of measurement we're working with, so we're going to say in our answer that it is 15.23 units long. If ever in doubt, you write units. So that seems a rather long way of doing this, and we're not always going to be given a picture or the time to be able to draw a picture. So we need to have a formula that works, that resembles Pythagoras, but is more friendly towards having coordinates rather than actual length. So here it is, the distance, or d, between the points x1, y1 and x2, y2. Remember, x1, y1 we can label over here because it's simply just the x and y value from point 1, and up the top here at point B we can say that is x2, y2 because they are simply both the x and y coordinate from the second point. The distance is given by a very big square root over the top of x2 minus x1 squared plus y2 minus y1 squared. Now, pulling apart this formula, going across the bottom, so dealing with our x's, x2 take away x1. So that means in our question, starting with the formula, we're going to have d equals a very large square root over the top of. Now x2 minus x1. Our x2 value is 7 minus our x1 value of -7. And we square that value. Adding on y2 minus y1. Now our y2 value was 8 minus our y1 value of 2, and our formula says to square that. Now 7 minus -7 means we have 14 squared, plus 8 minus 2 is 6 squared. Now from that you can start to see that that is where Pythagoras kicks in, and it's starting to look exactly like what we had, except in the first step in the formula it was a lot more coordinate friendly. We didn't need to draw a picture, we didn't need to work out the distance of the rise and the distance of the run of our interval. All we simply have to do is plug in our coordinates in the formula and that'll give us our answer. Because we had 14 squared plus 6 squared in our formula over here at the top right, we have 14 squared plus 6 squared underneath the square root sign here. Then we go on to square root our answer, and there is a giant square root sign over the top of our formula. So it is following the very exact same steps that we took, and we are going to get the same answer of 15.23 units. So that is the distance formula. The last one we needed to look at was our gradient. Now what is the gradient? What does it mean for us, and how is it useful? Now just basically at this point, the gradient is the slope of any given line, equation or interval represented in the number plane. What it's useful for is, if you're continuing on with mathematics, there are going to be a lot of calculations and a lot of real life examples that the gradient can translate into and what it means for working something out in the real life. At this point we just need to know what it is and the different variations. So the first variation of the gradient is the fact that if you have a dead straight line, so the line is parallel to the x-axis, it is a flat line, that means there is a zero gradient. That gradient is equal to 0. Converse to that, if you have a line going straight up and down, so it is a vertical line, it is parallel with the y-axis, that gradient is infinite. Just two situations to be aware of. And why they are 0 and infinite is because, again, the gradient is a measure of the slope. The zero gradient doesn't have any slope, it is just a flat line, whereas the gradient going directly up and down has an extremely steep slope. Two other variations of the gradient. If and when you go from left to right of your interval or equation, your graph goes up, that means you have a positive gradient. And if you go from left to right of your line or interval and your graph goes down, that means you have a negative gradient. So they're just four basic definitions to be aware of. Now we'll head into actually calculating the gradient. So here is our interval. There is a straight line going straight through our number plane, and we are asked to work out the gradient. So again, what we need to do is, to start off with, draw on our little right angle triangle. So here with the gradient, you can pick any 2 points you want. So I'm picking this point at the top right there, and this point right here down near the origin. So this point, first off, on the x-axis we go across 1 and we go up 2 to get to that point. So that is 1, 2. Over here we go across 9 and up 6 to get to that point. So that coordinate is 9, 6. And again, this is a nice little right angle triangle. So what is our actual definition of a gradient? Having a look here, the symbol for the gradient is m, and notice this one is a lowercase m. So this is how we tell the difference between a gradient and the midpoint. Now the reason that the gradient has a lowercase m rather than simply a g, which would make more sense, is because in mathematics and the world of physics, g was already taken by gravity. So they needed to come up with some other letter so that they could represent what the gradient actually is. In the formula there, it says the gradient, or the lowercase m, because mathematicians are lazy. Every time we want to use the gradient, we're not going to write the word gradient. And it's equal to the vertical rise divided by the horizontal run. So I started to use those terms last time. Here is the rise of the graph, and here is the run. So how far across does the graph go is the run, and how far up our graph goes is the rise. So simply, down here in the blue box, gradient equals rise over run. So the rise of our graph, we're going from, now the rise is going to be a measure of the y-axis, and the run is going to be a measure of the x-axis. So our rise goes from 2 to 6, so our rise is equal to simply 4. And our run, we go from 1 to 9, so our run is equal to 8. Using our little calculation over here, m is equal to our rise of 4 divided by our run of 8. Simplifying that fraction down, we simply have 1/2. So our gradient is 1/2. And what that means is for every 1 the graph rises by, you go across 2, and that'll get you back on the line. That is the slope. So starting at our point 1, 2, if we go up 1 and a run of 2, we're back on the graph. If we rise 1 and run 2, we're back on the graph. Rise 1, run 2, we're back on the graph. Rise 1, run 2, we're back on the graph. So that is all that simply means. That is the slope of our graph. Again, we're not going to have a picture. We're not going to have the time to draw a picture. So we need a more friendly way of doing it. The way we worked out 4 is we went 6 minus 2. We wanted the difference between the 2 and our 6, so you take them away from each other. So that's what the top line means down here in our formula, where lowercase m equals y2 minus y1. That is simply just the rise. x2 minus x1. In our case, we had an x2 value of 9 and an x1 value of 1, and that worked out our run. We wanted the difference between our x2 value, and we'll label our points x2, y2, and x1, y1. We needed the difference between the x's and the y's to give us the rise and the run of the graph. Following this formula, if we had our values of 6 minus 2 divided by our run of 9 minus 1, we have 4 over 8, which also gives us a half. So both the formula and the long way get us the same answer. So we're pretty happy with the fact that our formula will work for us every time. Okay, going on to that one big example that I promised. For the interval joining the point P, which is -2, 6, and the point Q, which is 3, 2, find all of the midpoint, the length, and the gradient of that interval. So, -2, 6. Our graph doesn't have any lines on it, so we need to go back, start at the origin, go back 2 on the x and up 6. There is our point P. Point Q, we need to start at the origin, go across 3 because x is always first, and up 2. And there is our point Q. And just to help us out, we will add on an interval so we can see what we are looking at. And there is our interval between point P and point Q. Now that's just to help you look at it. What we're going to do is, to solve these questions, we're going to focus on using the formulas that we just learned. So the midpoint is represented by a capital M, and the midpoint is equal to a coordinate, as the word suggests. It should be a point, and all points can be represented by a coordinate. To find the middle of anything, you need to find the average. So we have x1 plus x2, and then we halve it, and the y value is y1 plus y2, and then you halve it. So our x1 value is the -2 plus the x2 value, which is the 3, and we add those together and halve it. The y1 value is 6 plus the y2 value is 2, and we're going to halve that, and we close the brackets off for the coordinate. Now, giving myself a little bit more room, equals negative 2 plus 3 is 1, so we're going to end up with a half as our x value, and 6 plus 2 is 8, and half of that is 4. So our midpoint is equal to a half, 4. If we have a look at our little graph, start at the origin, go across a half, and up 1, 2, 3, 4. We end up on our line, and there is the midpoint. And it looks pretty good. Okay, solving the next one. We were asked to find the distance. Our distance is represented by a lowercase d, and remembering that formula, we need a giant square root sign to start off with. Then we have x2 minus x1 all squared, added on with y2 minus y1 all squared. So the x2 minus x1 is finding us the length of one of the sides of the triangle, created by making a right angled triangle with our interval, and the y2 minus y1 is finding out the second length of the side. So let's fill this in. x2, now point x2 was, going back up a little bit, 3 minus the x1 value of negative 2 all squared, plus the y2 value of 2 minus our y1 value of 6, and that was squared also. 3 minus negative 2 turns into 3 plus 2. So under our square root sign, we're going to have 5 squared plus 2 minus 6 is negative 4. So in brackets, we're still going to have the negative 4 squared. Under the square root sign, we have 5 squared is 25 plus negative 4 squared. Now because it's negative times a negative, it turns positive anyway. So that gives us 16. 25 plus 16, square root of 41. And we will call that the length of units, because we don't know if it's talking about centimetres, metres, or what kind of scale we're dealing with. A surd is the most accurate way of writing that answer, so we're going to leave it as a surd. Okay, the last thing we had to find was the gradient. The gradient is represented by a lowercase m, and the gradient is the rise over the run, which is also the same as y2 minus y1 divided by x2 minus x1, because they find us the length of the rise and the run. What I'm going to do is I'm going to pull those values from our distance formula. So the y2 minus y1 was the same as our 2 minus 6. So that was negative 4 divided by x2 minus x1. So down here, our x2 and x1 is the same as our x2 minus x1 in the distance formula, which gave us 5 in the end. And there we have it. Negative 4/5 is the gradient. Remember, if it's a negative gradient from left to right, your line is going down. So if we have a look at ours, yes, from left to right, our line is going down. So we're pretty happy with all three of those answers. Alright, that's it. Thanks for watching this video, and good luck.